So summing up, hash join versus sort merge join. Sorting has pros. Obviously, if the input's already sorted, we can skip the sort phase. And if we need the output sorted on the join key, that's nice. The sort merge join already does that for us. As we know, sorting is not sensitive to data skew or bad hash functions and generally has that advantage over hashing. So if you're worried about that on a particular input, or if your optimizer is worried about it, it can choose to do sorting instead of hashing. Now, hashing pros, note that for join, the number of passes depends only on the size of the smaller relation. If the smaller relation is really small, it fits in memory, then naive or hybrid hashing is going to be very efficient, and it's definitely the algorithm of choice because S only needs to be scanned once, even though it may be very, very big. Now, it's also good in hashing, obviously, if the input's already been hashed for some reason, or we need the output hashed, say for a group by. And so hashing has those pros as well. So to recap, nested loops join works for an arbitrary theta. So when we don't have equality, for example, we must use nested loops join. And if we're going to use nested loops join, let's use our chunk or block nested loops join, utilizing memory in big blocks of size b minus 2. Index nested loops join only works for equijoins. It's very nice if you have an index on one side of the join, on the join attributes. It's particularly good when the join is highly selective. For each tuple of the output, there's only one or a few matches on the input, or if the index is clustered. Remember, though, that index walking is random I/O, and sometimes, if you're comparing random to sequential I/O, you don't really even want to do random I/Os. Remember, random I/Os are often on magnetic disks 100 times slower than sequential I/Os. So you have to model your index nested loops join cost to take into account the random I/O cost. Sorting and hashing work for equijoins as well only. They don't require an index. In some sense, hash join builds an index on the fly, if you will, a special kind of join index. Hashing is better if one relation is much smaller than the other, right? You don't have to sort the bigger relation or hash the bigger relation with hashing, whereas with sorting you have to sort both relations. Amongst all of these, there are no clear winners. We do know among the plain nested loops join algorithms that block nested loops join is best. But between nested loops, index nested loops, and sorting and hashing, it's not clear that there's one of those that you can discard, and so you may want to implement all of them, and many systems do. Finally, you're going to want to know the cost model for each one of these algorithms, and if you don't use it, then your query optimizer should, right? So your query optimizer eventually is the algorithm that's going to choose among these based on what it knows about the input relations to be joined. So you have to understand the cost model in order to understand how we're going to do query optimization, which is coming up in a lecture very soon.